Hello and welcome to another tutorial. We are looking at Java language basics, and we are finally at the last two items, which is about switch statements and then switch expressions, which are a more modern version of switch statements. So let's start with switch statement. Now we saw that we can use if-else constructs in Java to basically do conditions, right? Conditional statements, do branching. And the switch is another way of branching, but it has some limitations. So basically it has some advantages and drawbacks or disadvantages. Using switch statements to control the flow of your program. Usually we use switch statements with things that have a limited set of possibilities, and the obvious example is enums, right? So enum, you specify how many possibilities are there based on the enum things that you put in your define in your enum, and then switch can easily basically branch on them, and then based on each case, then you can decide what is happening. Now the switch statement by itself, it couldn't return a value. That's why they eventually introduced switch expressions. So let's start with switch statements. The switch statement is one of the 5 control flow statements. So we saw if, else, other control flows were loops, right? Non-conditional loops are basically while, for, and we saw that loops are also kind of associated with conditions, because in order to terminate a loop, you have to do some sort of conditional checking, right? You have some statement, you put a condition on it, you check its Boolean value, and then decide whether to terminate the loop or not, right? So switches are also part of the control flow statements available in the Java language. It allows, and again, this comes from the fact that they designed Java to be similar to, for example, C or C++, and in both of those languages, switch statement is available. So they also introduced in Java, but they made it more easily usable, right? So switch in Java follows more stricter rules, just like any other thing, so that it avoids confusions, or it makes the code more readable. It allows for any number of execution paths, and you define them with case. A switch statement takes a selector variable, so you cannot really define an expression for the condition, unlike the if or else if statements, that the parameter or the argument to the if or else can be an expression which will evaluate it to a Boolean value. But for switch, you can't really do that. So you have to put a variable, and that variable doesn't have to evaluate to Boolean, but it has to evaluate to basically whatever you're switching on. And I'll show you what I mean by switching on a type. Takes a selector variable as an argument and uses the value of this variable to choose the path that will be executed. You must choose the type of your selector variable among the following types. So this is the main restriction on the switch statements. When you switch on a type, it has to be either an integer type or a character, so basically wrapper types, or an enumerated types, or a string types. And this all comes down to the fact that the switch searches or tests for exact equality. That's why you cannot do exact equality on floats or doubles, right? We discussed this in the past, that exact quality for floating point numbers doesn't make sense. That's why you can't really switch on a floating point primitive, for example. Same with object references. You don't want to switch on an object reference, because exact equality, it doesn't call the equals method, right? It checks for reference equality, which doesn't make sense in most cases. However, enums are exceptions, because they have a limited set of possibilities. It is worth noting that the following primitive types cannot be used for the type of your selector variable. Boolean, so you cannot switch on Boolean because there's only 2 possibilities, either true or false. It doesn't make sense. Long float, we cannot test for exact equality, or double. So float, double, these we cannot test for exact equality. Long, it also doesn't make sense. I guess it could make sense, but they decided not to allow that. So you can only switch on 32-bit, maximum 32-bit integer types. So you cannot really switch on the long type. So no Boolean, no long, no float, no double. 64-bit primitives, they're not allowed, whether integer type or floating point types. And also Booleans are not allowed, because it just doesn't make sense, right? Let us see a first example of switch statement. So I'm going to basically, maybe in the conditionals, I'm going to create a new class, switch a statement, and let's have a main method here, and I'm going to define one public static void test1, and I'm going to execute test1, and here I'm going to just copy and paste this. Let's see. So and then quarter, this quarter is a integer type, and let's set it to, for example, so one of these 0 1 2 3, right, on default. So let's set it to 0, for example. Now and then let's eventually do a print on the quarter label here, which is what we are assigning when we switch on the cases. So how does switch work? So you write the switch statement just like if, else, while. It also takes one argument, right? And the argument doesn't have to evaluate to a bool. It doesn't have to be conditional, and you are not allowed to put a conditional statement. You cannot say quarter greater than 5 here, because this should not evaluate to boolean. You cannot switch on a boolean type. So when we say switch on some type, means the type of argument that goes in the switch, in the argument or the parameter of the switch. So you cannot switch on a boolean type. If you want to do that, you just go use if else, right? That makes more sense. And but you can switch on int types. What this means is that and again, switch, the whole point of switch to test for exact equality. Now obviously with integer types it's always possible to test for exact equalities, and here what we're doing, we're putting cases, and the convention is that you have a case, and then the syntax is the value you test for different values. Note that these are not statements, right? If I say quarter minus 2, this still works, so because this statement gets evaluated and the result is still an integer, right? So you can put a statement here if it evaluates to any of these allowed types, or I can say 2 times quarter, for example, plus 3. This is also allowed. The compiler doesn't give us any warnings because at runtime this expression will be evaluated. But let's remove this, and the best practice is to not put any expression here, just put the final variable or whatever, because it makes the code more readable. So we switch on something of an allowed type, and then we put cases. Case 1 means test if this argument is exactly equal to this case. If it is, we do something, and then we have to break. If we don't break, something called fall through happens, and the next cases will also be evaluated until you hit the break. And that's a very bizarre behavior for switch and case, but again, that's because the same thing happens, I guess, in C, C++, and they wanted to this switch to be also similar. Because the thing here is that sometimes you want to test for multiple cases. Let's say I want something happens if this quarter is equal to 0 or 1. Then all you have to do, you have to remove this break. If you do it, if quarter is 0, this will be evaluated, and then this will, the case 1 will also be evaluated. The very first case that matches will be evaluated, and all of the other cases will be evaluated until you hit a break. So again, you have to be cautious, and my recommendation is that always try to use break. So don't rely on fall through. That's one of the best practices, is to avoid relying on the fall through behavior of the switch. So let me just make this code more clear what's going on. And the default is when none of the cases match the argument, the value of the argument that we're switching on, then it just goes to the break and to the default. And default doesn't have to be the last statement. Some people make this mistake or assumption that default has to be the last statement, but it doesn't have to be the last last case or last expression, right? So let me run this and let's see what we expect. So the value is 0, we switch on this quarter, and then the first match or the first exact match is 0, so this quarter label becomes Q1, and then we break, which means we don't execute the other cases. We immediately break out of the switch. So and and then we come here and we print this. So this should give us Q1. Yes. Now if I set this to 1, and by the way, before that, let's see what happens if I didn't have this break. For the case 0, the first match doesn't have a break. Then as you can see, Q2 gets executed. Why? Because we get this first match, and then quarter label is this one, but then we fall into the trap of fall through, which means in the second case, the condition is not going to be evaluated again. In the switch case, only one case that is true is evaluated. Later cases, the cases that come after that, the condition is not checked again. So if fall through happens, other case conditions are not tested again. So the first match that happens in the switch, then the behavior is like the other cases. These are like not there, right? You don't test again. So that's the behavior of the switch. When the very first case that matches, the other cases are never re-evaluated or retested again. But then if you don't hit a break, it's like the other case. In this case, like case 1 is not there. So you evaluate this, and then the second one here is evaluated until we hit the break. And to prove this to you, we can also remove this break. And now what happens here is that when the first match is case 0, right, the exact match, and this gets executed, and then it's like the other cases are not there. So the second here is executed, there is no break, so we fall through to the next one. This is going to be executed, and then we hit the break, we jump out of the switch. And as you can see, Q3, right? So be very careful about the fall through. The recommendation is that always add a break to each cases. That's the safest path to take. And then let's see what happens now if we add 1. Now case 0 is not the match, right? The first exact match is case 1, and we get Q2. And if I don't hit the break, then this part is not to be executed because case 0 is not a match. Case 1 is the match, and then the other cases will never be tested again. So it's like this statement, this one, and break. And obviously when we jump out, when we hit this break, the value of the quarter label is Q3. As you can see, Q3. So I hope you really get a grasp of this fall through, and it sometimes feel like it's a weird behavior, and honestly there's not much use case for fall through, but then sometimes it makes sense to use it, but most of the time it doesn't. So try to keep this break. And the other thing is that you don't really need to have a new line. And the other weird behavior is no scope for basically case expressions. What this means is that we've seen that for if or else, whatever, you have to define a code scope and put it here, right? And we can do this with case, but it's not necessary, because again, when the first match happens, the other tests are, it's like they're not there anymore, so they become invisible. So we could in fact create a scope, but the best practice or the recommended style coding, so this is more like the style of coding, is that you don't really need the scope, right? So if I set this back to 0, obviously the body of the case is going to be executed, and we jump out. What if we remove this break? Does this explicit scope make any difference in the fall through? The answer is no, right? So for the case, we typically don't use a pair of curly braces to have a explicit scope. That's the exception. In all other cases like if, while, else, all those constructs, the recommendation is always use a explicit scope for your if. Here we define an explicit scope for switch. Now if you don't do that, then it doesn't work, so you get a compilation. So you have to define the scope for the switch. But then for cases, we use a colon. And if you're familiar with Python, for example, you know that in Python there is no concept of curly braces. You always use this colon. It's very interesting that case with the colon kind of matches the Python style. For example, in Python you say that if quarter, I mean in Python you don't have a switch construct, but you can use an if, right? If quarter equals 0, and then colon, and then you put your conditions exactly like this, right? You hit the line break, go, and then write write the condition, and you can also have a break in Python. So it's kind of similar to the if construct in Python. You use a colon, and then you don't use a pair of curly braces, you just put your code here. But again, all these new lines, everything here is not necessary. You can even put them on the same line. So actually I can copy and paste this here, and then even put the break on the same line. This is totally valid, and sometimes it makes code more readable if you only have one statement. Note that you cannot separate these statements with comma, right? You have to separate them with semicolon, which means you can have multiple statements, but the break can be also on the same line. So they can be on the same line, and that's perfectly valid. So if you think it makes your code more readable, if I use the auto format, the default style of Eclipse, Command Shift F, as you can see, Eclipse follows the style of having a new line or line break after the case, and then put the conditions and then the break on the next line. So Eclipse kind of follows this formatting guideline. The other thing here is that after the scope of the switch, you kind of need to have this semicolon. Or actually, you don't need that. So the only where that you need that semicolon after scope, it was for the do while loop. But for switch, for example, you don't need that. As you can see here in the code, they have this semicolon, but it's really not necessary. So if I run this, it's going to still work fine, right? So the obvious question is, what happens if we don't match any of the cases? And that's when the default gets executed. As you can see, unknown quarter. And as I mentioned, basically, the default doesn't have to be the last case, right? I can put it right at the beginning, and this still works fine. Basically, Q1 winter. Okay, so the reason that it's interesting, the reason that we're getting this, it's because, again, that's because of the fall through, right? So be very careful, because after the default, I don't have a break here. So if you don't put the default at the end, be very careful to add a break. Otherwise, so if you don't add break here, you get fall through, right? Because default doesn't have any condition, which means this has to be executed, because obviously this makes sense, right? This matches, because regardless of the value here is, this statement matches, because there is no condition to test. And we said that in the switch, when there is no condition to test, when the first case that matches, remember, default is also a case statement. It's the default case statement that doesn't have any test, and it's guaranteed to match. The problem is that if it matches, then the rest of the cases are basically invisible. So you jump into a fall through if you don't have a break. So let's see if I run this. Now I get unknown quarter. If I don't have this break, then we match the default, right? Because the other cases don't match. So we execute this. After we execute the default, the rest of the cases are invisible. So this executes, and the next line also executes, and then we hit the break, which is not the condition what we want, right? So always the best practice is to put the default at the end, and then you won't need a break. And obviously the best practice is to add the break even to your default. So best practice is to add the break even to your default case, so that if somebody later on tries to move the default up and down, then basically nothing breaks, right? So I hope you enjoyed this lecture. In the next lecture, we will look at the switch expressions. So please stay tuned, and I'll see you in the next one.